Okay, we're starting section 9.2, and going through the slideshow on this one, we're going to classify different chemical reactions, identify the characteristics of different classes of chemical reactions, and we'll review there, go to some vocabulary. I'm going to talk about synthesis reactions, combustion reactions, decomposition, single replacement, double replacement, give a good definition of what precipitate is. The four types of chemical reactions that we're talking about here. The main idea is that we have these four types: synthesis, combustion, decomposition, and replacement reactions. These are the four main types of chemical reactions that we're going to talk about today. Chemists classify reactions in order to organize the many types of reactions. First one is the basic one, a synthesis reaction. Two or more substances react to produce a single product. So they have this example here. When two or more elements react, the reaction is always a synthesis reaction. You have sodium and chlorine reacting to form salt, sodium chloride. They show it here with the two big sodium molecules reacting with the chlorine. Remember, the chlorine is a diatomic gas. It's got two molecules there. They react to form two separate molecules of sodium and chloride. So that's a synthesis reaction. Two things combine to form one. And a combustion reaction. Combustion means something burns, right? Oxygen combines with a substance and releases energy in the form of heat and light. In this, I've written this up the other day. This is a heated hydrogen reacts with oxygen to produce heat and water in combustion reaction. This is also a synthesis. It's oxygen and hydrogen combining to make water. We call it a combustion because it has the water and the oxygen combined together to create the hydrogen and the oxygen combine together to create that. Notice that the hydrogen is a diatomic molecule, and so is the oxygen. They combine to create two water molecules, and because we're using oxygen, just O2, that's classified as combustion reaction. Decomposition reaction. One single compound breaks down to form two or more elements or new compounds. This is when something breaks down or rots, and you usually need some kind of energy source to get this started, like heat, light, electricity to break it apart. Replacement reactions, one in which the one element replaces the atoms of another element in a compound, is called the simple replacement reaction. They show kind of the generic form of this reaction where you have an element A and a compound BX, and the element A replaces the B and A switch places, right? The A is now with the X atom, and B is off by itself. So B was replaced in this reaction. This most often happens with metals. A metal will not always replace a metal when it's dissolved in water because of differing reactivities. And we have this activity series over here that popped up on the right side. And the most active are at the top. These metals will always, and the way this chart goes is the metals on top will replace the ones below them. So lithium will replace everything on this chart. Sodium will only replace magnesium, aluminum, and manganese, zinc, so on down the list. Iron will replace nickel, tin will replace lead, copper, silver, and gold doesn't replace anything. It's the released active. And the halogens, it just goes right down the group of the halogens, starting at fluorine on the top, going down to iodine. So as we go down the group, it's least reactive. And we can use these. Some people have asked me why, why reactions occur, and we can see this activity series of why sometimes it'll happen and sometimes it won't. If we have a more active metal, we'll replace a less active metal in a reaction, but not the other way around. Halogens frequently replace other halogens in replacement reactions, but halogens also have a different reactivities and do not always replace each other, right? Nothing can replace a fluorine because that's the most active one, but other halogens could replace each other. Double this replacement reactions occur when ions exchange between when ions are exchanged between two compounds. So we have kind of the generic double displacement reaction here, where double replacement, displacement, replacement. I've heard it heard both ways. So the X is with the A, and it gets transferred to the B. So the X and the B are together, and the B and the Y are together. They change places. So these two change place, and they show an actual reaction here with calcium hydroxide reacting with hydrochloric acid, and it becomes calcium chloride and water. Okay, so the calcium gets, and the chlorine, the hydrogen goes with the hydroxide and becomes water. The calcium switches with goes away from the hydrogen and gets with the calcium and becomes calcium chloride. The solid product produced during a chemical reaction in a solution is called a precipitate. We've kind of gone over this before, but this is a good definition of it. So if you have two chemicals reacting, two solutions reacting together, and you get a solid is produced, something that's not soluble in that solution anymore, that's a precipitate. All double replacement reactions produce one of these three things, or both, or more of them: a water, a precipitate, or a gas. This table shows the steps to write double replacement reactions. Okay, this is probably the hardest ones we have to do in chemistry, as far as starting out from, if they just give it to you from scratch, a word equation saying everything written out how you have to do it. So this is aluminum nitrate and hydrochloric acid, or sulfuric acid, sorry, reacting together. Okay, so double displacement reactions, we have to identify the anions and the cations in each compound. So we do that. The anion here is aluminum. The cation is the nitrate. The the hydrogen is the cation, and the anion is the sulfate. So what happens in double replacement? They switch places, right? The aluminum now gets with the sulfate, and the hydrogen gets with the nitrate. So we switch those, balance those two things, right? We have the 3 and the 2. Remember, we kind of switch the 3 and the 2. The 2 goes down here on aluminum. The 3 goes on these two switch, and the 2 becomes the subscript for the aluminum. The 3 becomes the subscript for the phosphate. They're balanced out, right? +6, -6. And the same thing, you kind of, the OHs, the NO3 and the H are just 1 to 1. So you put that together, and this is kind of unbalanced equation over here on part 5, has the aluminum nitrate, sulfuric acid reacting to form aluminum sulfate and hydrogen and nitric acid on that part of it. So to balance it out, though, then we have to balance the equation with coefficients. So we put a 2 in front of the aluminum to balance out. We need the two aluminums on the product side. So you put a 2 there, and we have to work it through, and we put a 3 in front of that. It gives us 6 HNO3s on the other side. So follow these steps as far as writing the equations for the balanced equation. It's pretty much the same ones we do for the other ones, but you'll have to identify these, and sometimes you have to identify the products here, which is the tough part of that. And then you have to balance these compounds to get the right ratio of aluminum and sulfate and hydrogen and nitrate. Okay, so this is a good table for summarizing what happens, different ways chemical, the synthesis, the combustion, the decomposition, the single and double replacements, what happens to the reactants, two or more form one compound on the synthesis part, and the little part over here, the AB part, is what it looks like, the two things combined to make one. Combustion always involves oxygen, and it always looks like this. Something combined with oxygen makes something with an oxide. Decomposition, we start with one thing and you end up breaking down to two or more. It's the opposite of synthesis. Single replacement, one thing replaces another in the reaction. Double replacement, two things switch, right? On this, the two, and they always get a solid water or a gas after they switch. Okay, I don't need to do that. There's a discard. There's a nice chart here. I'm going to give you guys a handout. You don't have to write this down. I'm going to give this out to you guys in class, showing the activity series of different metals and how they go. So don't worry about that. And fill out the form and ask any questions. You might have more than normal on this one. So see you in class tomorrow.